All right, so here is the last of our videos, and I'm going to answer, let's see, what are we looking at? Practice for dimensional analysis, and we are going to answer question 3. If we are not able to go to school for 3 whole weeks, how many chemistry classes did we miss? Well, 3 weeks. How many Monday, Tuesday, Wednesday, Friday classes are there? There's 4 in a week. So since there's 3 weeks, we can times that by 4. That's 12 Monday, Tuesday, Wednesday, Friday classes. And then how many Thursdays? Well, we're missing school for 3 weeks. That means we're missing 3 Thursdays. So we're going to miss 3 Thursday type classes. All right, so how many did we miss total? 15 classes. It's kind of a lot. Kind of makes me sad. Okay, so I guess the question is, how many hours of chemistry did we miss? And so this is what our given is. So here's our given. And the question is, how many hours? So we're going to need to convert our classes to hours. And we know that the Monday, Tuesday, Wednesday, Friday class is equal to 57 minutes. And we also know that our Thursday type class is equal to 47 minutes. But we also realize that we are converting not to minutes, but to hours rather. So we know that there is 60 minutes in 1 hour. Okay, so those are the conversion factors that we're going to need. So I guess we'll do classes to hours and then hours to minutes. All right, so let's do it. So we have 12 Monday, Tuesday, Wednesday, Friday type classes. And we know that in one of those type classes, that is 57 minutes. We also know that there are 60 minutes in 1 hour. So this is a multi-step conversion. So we can cancel this. We can cancel our minutes and we'll be left in units of hours. So we need to just do that math. And that would be 12 times 57 divided by 60 minutes. And that turns out to be 11.4 hours. All right, then we also have 3 of our Thursday classes. And we know that in a normal Thursday class, that is a 47-minute period. And there are 60 minutes in 1 hour. So our Thursdays cancel, our minutes cancel, we're left in hours. So we'll take 3 times 47 and divide that by 60. Oops, hold on. 3 times 47 divided by 60. And that gives us 2.35 hours. Okay, so then we need to add these up. But we need to think about this for a minute. So we need to identify our sig figs. So this isn't exact because we're counting. This is to 2 sig figs. 2 sig figs. And then this is also exact because that's defined. So here's where our significant placeholder should be. So let's go ahead and add these. So we have 5, 7, 13, and 1. But we need, well, remember when we're adding, we can only add to the least precise decimal place. So sorry these aren't lined up all perfectly, but that means that we have to round to right here. So that's about 14 hours of chemistry. So sad that we're missing because of COVID-19. All right, so there's the answer to that part. So now let's see. How many minutes is this? How many seconds is this? How many years is this? And then we'll figure out how many decades this is. So how many minutes is 14 hours? Oops. So we're going to need to go from hours to minutes. And our conversion factor is 1 hour equals 60 minutes. So we say 14 hours, 1 hour is equal to 60 minutes. And when we do that math, we get 14 times 60, we get 840 minutes. As far as sig figs go, this is 2 sig figs. This thing is exact, so we'll have to round our answer to 2 sig figs. So here is our significant place value. So we'll just put a little line under that. 840 minutes of learning. Oh my gosh, that seems awful. We're going to miss that. All right, well, let's make it worse. How many seconds is that? So we're going to need to convert from minutes to seconds. We know that in 1 minute, there is 60 seconds. So let's take what we know. We're going to miss 840 minutes of school, well, of chemistry. And we know that in 1 minute, there is 60 seconds. So our minutes cancel, and we need to multiply 840 times 60. That is 50,400 seconds. But as far as sig figs go, wow, my screen's going crazy. Sorry. 2 sig figs here. 1, 2. We don't count that 0 because we're not supposed to. This one is exact. So that means we have 2 sig figs. We need to round to this place, so we look at that 400. That means we round not to 50, you guys, but to 50,000. And then because that's ambiguous, we'll just put a line under the 0 to show that that is the significant place value. And our units are seconds. 50,000 seconds of chemistry is what we're missing. Sounds awful. Sounds like a huge amount of time. All right, let's get a little perspective on this. How many years is that? So here's the thing. We've got 14 hours, 840 minutes, and 50,000 seconds. You do realize all 3 of those figures are equivalent. It's just that they're in different units. So if we were going to convert one of those into years, I'd pick the one that's the closest to years. So I will pick this one, 14 hours. So let's start with 14 hours. That's going to be our given. What we want is years. So we're going to need to convert from hours to years, but I don't exactly know that. So I'm going to convert hours to days and then days to years. Because I know that there is 24 hours in 1 day, and I know that there's 365 days in 1 year. So I'm going to use that to get to my answer. All right, let me move this down. Okay, so 14 hours, and I know that there is 24 hours in 1 day, and I know there's 365 days in 1 year. So I make sure that the hours cancel, the days cancel, and I'm left in years because that's what it's asking. And then I do the math. So I'll take 14 and I'll divide that by 24, and I'll divide that by 365, and I get 0.00159,817 years. But as far as sig figs go, this is 2 sig figs. This one is exact, and this is also, well, this is not exactly exact, right? Because we just had a leap year. So this one's 1, 2, 3 sig figs. But it doesn't matter. 2 sig figs is the least significant, so we're going to have to round to 2 sig figs. So that means we're going to round to 1, 2. We need to round to right here. Remember, these are placeholders, so we don't count them. All right, so I'm going to look at the 9, and that means 0.0016 years of chemistry is what this COVID-19 is causing us to miss. All right, that doesn't seem so terrible. 0.0016 years, no big deal. Let's figure out how much decades this is. All right, so if I can go from years, oops, let's write in blue. So I need to go from years to decades, because that's what we're looking for now. And I know that there is 10 years in 1 decade. All right, so I'm going to take my given, 0016 years. I'm going to convert that to decades. That means there's 10 years in 1 decade. My years cancel. I'm left with this really, really small number. My sig figs are all correct, by the way, because this one was 2 sig figs, and my answer's still 2 sig figs. This is so small that I'm feeling like, hey, let's put this in scientific notation. So I'm going to move the decimal over 4 places, and I get 1.6 times 10 to the, it's a little number to begin with, so this is -4 decades. So here's the deal, kiddos. Is COVID-19 really going to matter in 10 years as far as your chemistry learning goes? Probably not. You're missing 1.6 times 10 to the -4th decades of time in chemistry. So quit stressing. We're going to be fine, and we're not missing too much school. All right, so as far as question number 4, I think now you might have an idea of how to set that up and have fun making up your own problem and solving it. All right, well, stay tuned. I've finished answering all these questions, and I will talk to you at a different time. Bye, guys.